Hello, welcome to our first day of the week for Eureka. So we're starting with our objective. Today you are going to be able to find and interpret the constant of proportionality in contextual or real-world problems. Remember that the constant of proportionality is also known as the unit rate. Okay, we're going to do two examples together using constant of proportionality and tables to help us come up with equations and solve more complicated problems. We're going to do a couple together, and then you're going to do a couple on your own. Here's the first problem. Wildlife conservationists are concerned that the deer population might not be constant across the national forest. The scientists found that there were 144 deer in a 16 square mile area of the forest. In another part of the forest, conservationists counted 117 deer in a 13 square mile area. Yet a third conservationist counted 216 deer in a 24 square mile plot of the forest. It's asking us what the population density of deer per square mile. So whenever we are looking for anything in a proportional relationship, we're always going to start with a table. So start with your table. You can build a table either way, tall ways or sideways. I often prefer a tall table. And the most important part of a table is how you label it. So we are going to do deer and square miles. Square miles. Now, the y is is always the dependent variable, and the x is always the independent variable. So the y is depending on the x. So in this case, the number of deer depends on the size of the forest. So this is going to be square miles. And we have our x and our y. Sorry, that's a little bit squished. Okay, so now we're going to put each of these into our table. We have 144 deer in 16 square miles. We have 13 square miles with 117 deer, and 24 square miles with 216 deer. So, it's asking what the population density per square mile is. Per square mile tells us that it's asking about a unit rate. A unit per square mile. How many deer per 1 square mile? Well, we can find that out by finding the constant of proportionality. Constant of, I'm going to abbreviate it, constant of prop, is going to be our y over our x. We have three ratios here. We have 144 over 16. We have 117 over 13. And we have 216 over 24. If we get our calculator and we divide, 144 divided by 16 is going to be equal to 9. 117 divided by 13 is also equal to 9. And 216 divided by 24 is also equal to 9. So right away, we can tell that this relationship is proportional because all of our constant of proportionalities are equal. The unit rate of deer per square mile is 9. Our constant of proportionality is the same thing, it's 9. So we're dividing the number of deer by the number of miles. It's always going to be your y over your x. So it's asking us to explain the meaning of the constant of proportionality. That means, what does this 9 mean? So we're going to say 9 means that in 1 square mile, because it says per square mile, so we're dealing with 1 square mile. 1 square mile, there is, in this case, it's an average, because the deer don't just stay in one place all the time, of 9 deer. So now that we have found our constant of proportionality, we're going to use it. So use the unit rate of deer per square mile, which is 9, to determine how many deer there are for every 207 square miles. What we're going to do is we're just going to extend our table. So if there's 207 square miles, we know that this number divided by this number gets us 9. This number divided by this number gets us 9. This number divided by this number gets us 9. So we know that whatever this is divided by 9 is going to give us 207, which means that 207 times 9 is going to give us the number of deer. So we have the square miles times 9 equals the number of deer. Oops, sorry, you couldn't see that. 207 times 9 is, calculator, or do it on your scratch paper, 1,863 deer. 1,863 deer. We can go the other way as well. So if we're moving from miles to deer, we are multiplying by 9. If we're going backwards, we are dividing by 9. So if we're looking for the size where we would find 486 deer, I'm going to redo our table down here. Miles, deer, square miles. Sorry. Okay. So we know that we have 486 deer, and we know that going from miles to deer, we multiply by 9. So deer to miles, we're dividing by 9. What do we get when we take 486 and divide it by 9? We get 54. Just to confirm that if we take 54 times 9, we get 486. 486 divided by 9 gives us 54. So there, the answer would be, what are the number of square miles? 54 square miles. So we're using our constant of proportionality to go back and forth in our tables. From x to y, you're multiplying, y to x, we're dividing. Okay, let's look at one more. This one was pretty messy. So let's look at one more just to confirm. Here we have Brandon. Brandon came home from school and informed his mother that he had volunteered to make cookies for his entire grade level. He needs 3 cookies for each of the 96 students in 7th grade. Unfortunately, he needs the cookies the very next day. Brandon and his mother determined that they can fit 36 cookies on 2 cookie sheets. The question is asking, is the number of cookies proportional to the number of cookie sheets? So, we're going to make our table. First thing, always the first thing. We have, it's explicitly telling us number of cookies and number of sheets. So we have number of sheets is our x, and number of cookies is our y. The number of cookies that we can make depends on the number of sheets that we can make. So we know that we can fit 2 sheets, 36 cookies on 2 sheets. On 1 sheet, how many can we fit? So we're going to do the same thing. We're going to find our constant of proportionality, which is y divided by x. In this case, In this case, that is 36 divided by 2. 36 divided by 2 is 18. So that tells us that our unit rate is 18, which is the same as our constant of proportionality. And for 1 sheet of cookies, that means that we can make 1 sheet, we can make 18 cookies. What does the constant proportionality mean in this problem? Well, 18 means that on 1 cookie sheet, he can fit 18 cookies. Okay, so now our question asks, how many cookie sheets will be necessary to make cookies for all of the students? So if we have, first we need to figure out how many cookies. It says 3 cookies for each of the 96 students. So that means we're making 96 students times 3. You're making 288 cookies. Now, we know that 288 is the number of cookies, so it's going to go here. Now, let's think about our directions. If we're going from sheets to cookies, we are multiplying by 18. If we're going backwards, we're dividing by 18. So if we want to get this missing number, are we going to multiply or are we going to divide? We're going to divide by 18. And we're going to get 16. So we will need 16 cookie sheets. So, in conclusion, the constant of proportionality is the number in a proportional equation that x is multiplied. Ooh, wow, we got lots of typos here. That x is multiplied by to get y. So we have 16 times 18 gets us 288. 2 times 18 gets us 36. That is our constant of proportionality. You have a couple to do on your own. Remember, focusing on your table, focusing on multiplying to go from x to y, dividing to go from y to x.